October 1942, the Barricadi gun factory, Stalingrad. The building has no roof. Half the walls are gone. A German soldier moves through what was once a machine shop, stepping over rubble, ducking under collapsed beams, rifle raised. Somewhere ahead, in the wreckage of what had been a working industrial complex 3 months ago, Soviet soldiers are holding a position the size of a room. The German's rifle is a carabiner, 98K. It is a fine weapon, bolt action, accurate to 500 meters, designed with the care and precision that German military manufacturing was known for. In this space, between these walls, at this range, it is almost completely wrong for the job. He needs to clear a room. His bolt gun fires 1 round and then requires him to cycle the action, raise the knob, pull back, push forward, turn down to chamber another. The man he is about to walk into is holding a weapon with a 71-round drum magazine and a cyclic rate approaching 1,000 rounds per minute. The distance between them when they make contact is 6 meters. The PPSH-41, Pistolet Pulemiot Spagin's machine pistol, is about to demonstrate why it exists. It was not designed for long-range duels across open ground. It was not built to impress anyone with fine tolerances or polished components. It was built for exactly this: a ruined building, a dark corridor, a man who needs to put a large number of bullets into a small space faster than his opponent can react. What it was made from and who made it and how it ended up in this building, in this city, in this moment, is a story that begins not in a weapons factory but in a furniture workshop, and in a lesson the Soviet Union learned the hard way in the frozen forests of Finland 18 months earlier. To understand what drove the PPSH-41 into existence, you need to understand what preceded it and why the Red Army in the summer of 1941 was catastrophically under-equipped for the kind of fighting that was about to define the next 4 years. The Soviet Union's first serious submachine gun was the PPD, Pistolet Pulemiot Degtyaryov, designed by Vasily Degtyaryov and entering mass production in 1934. Degtyaryov was a respected designer, and the PPD was a capable weapon. It was also manufactured almost entirely from milled steel, precision-machined components that required skilled workers, specialist tooling, and significant time at every step. The PPD-40, the final variant, cost 900 rubles per unit and required 13.7 hours of machining time to produce. Those numbers mattered enormously in the context of total war, but Soviet planners had not yet fully understood why. The PPD was treated as a specialist weapon, expensive enough to be husbanded rather than distributed widely. By mid-1941, despite years of production, fewer than 90,000 PPDs had been issued across the entire Red Army. Then came Finland. The Winter War of November 1939 to March 1940 was, as covered in the previous episode, a military catastrophe for the Soviet Union. But among the specific tactical lessons it delivered, one stood out with unusual clarity. Finnish ski troops, operating in dense forest and at close range, used a weapon called the Suomi KP/-31 to devastating effect against Soviet columns. The Suomi was a Finnish-designed submachine gun, high quality, well-built, firing a 7.62 by 25mm Tokarev-compatible cartridge from a 71-round drum magazine at around 900 rounds per minute. Finnish soldiers used it from ambush, emerging from tree lines at distances where individual rifle accuracy was irrelevant, and pouring automatic fire into Soviet columns before vanishing back into the snow. At the time, Finland had only around 4,000 KP/-31S in service. They didn't need more. In the specific conditions of winter war fighting, the volume of fire they delivered changed the shape of every engagement. Soviet commanders noticed, after 105 days of watching carefully aimed bolt-action rifle fire, failed to stop Finnish ski troops, who moved fast, closed quickly and fired continuously. The Red Army's leadership arrived at a conclusion that should have been obvious earlier. For close-range fighting in forests, built-up areas, and any environment where distances were measured in tens of meters rather than hundreds, a soldier with a submachine gun defeated a soldier with a bolt-action rifle almost every time. The maths was simple. A man who could fire 900 rounds per minute beat a man who could fire 15. Range was irrelevant when the range was 6 meters. The problem was the PPD. It was too expensive, too slow to manufacture, and too scarce to field in the numbers that a genuine mass distribution policy required. The People's Commissariat of Arms understood this. In 1940, they issued a requirement: design a submachine gun that matched or exceeded the PPD's performance, but could be manufactured quickly, cheaply, and by facilities that did not necessarily have experience with precision weapons manufacture. The man who answered that requirement was Georgy Semyonovich Shpagin, and his background explains why he was the right person for it. Shpagin was born in 1897 to a peasant family in Klyushnikovo, in the Vladimir region. He received 3 years of schooling and then became a carpenter at 12. He was not a trained engineer. He had no formal design education. When the First World War came, he was conscripted into the Russian army in 1916, assigned to repair artillery, and discovered through that work a talent for understanding how mechanical systems worked and how to make them work better. After the revolution, he joined the Red Army as a gunsmith and eventually began working at the Kovrov Arms Factory, the same facility that produced the PPD. By 1938, he had co-designed the DSHK heavy machine gun with Degtyaryov, a weapon that is still in production and active service today. But it was in 1940, responding to the requirement that came directly from the Winter War's lessons, that Shpagin produced his defining work. His central idea was not complex, but it was revolutionary in the Soviet context. Instead of machining components from solid steel, cutting and shaping and grinding expensive billet stock with skilled labor tooling, he would build the weapon from stamped sheet metal. Stamping was a forming process. A hydraulic or mechanical press drove a shaped die into sheet metal, deforming it into the desired profile in a single operation. It was fast. It required far less skilled labor than machining. The tooling was simpler. And critically, the process could be performed by any factory that had a large enough press, which included, among other facilities, furniture manufacturers, automotive body shops, and kitchen equipment producers. Factories that had never made a weapon in their lives could be converted to PPSH production in weeks rather than months. Shpagin submitted his prototype in September 1940. Testing showed it was reliable across 30,000 rounds, fired without significant parts failure, a figure that Soviet historian David Bolotin, writing in his authoritative work on Soviet small arms, cited as demonstrating the weapon's robustness. In the competitive trials of November 1940, it outperformed the competing design submitted by Boris Shpitalny. On December 21, 1940, the PPSH-41 was officially adopted by the Defense Committee of the Council of People's Commissars. Production was ordered to begin immediately. 6 months later, Germany invaded. The weapon itself, once you understand what it was optimized for, makes complete sense. It was 843 millimeters long overall, a relatively compact package given the 269 millimeter barrel length, and weighed 3.63 kilograms unloaded, rising to approximately 5.45 kilograms with a loaded 71-round drum. That weight was meaningful. It was heavy enough that the recoil of the 7.62 by 25 millimeter Tokarev cartridge was manageable in full automatic fire, particularly with the muzzle compensator Shpagin had incorporated, a feature that reduced muzzle rise during sustained fire and improved shot grouping by approximately 70% compared to the PPD. The selector switch allowed semi-automatic fire for ammunition conservation and full automatic for close assault. The receiver hinged at the magazine housing for cleaning, a practical detail that mattered enormously on the Eastern Front, where mud, grit, and extreme cold entered mechanisms and required regular maintenance. Open and clean the weapon in 2 motions. Soldiers could do it by feel, in the dark, in freezing temperatures. The barrel was chrome-lined, a significant durability feature that extended barrel life substantially beyond what unhardened steel permitted and made the weapon more resistant to corrosion. That chrome-lined barrel came from an ingenious logistics solution. Rather than tooling up a separate production line for PPSH barrels, Soviet planners simply cut Mosin Nagant rifle barrels in half. Each Mosin barrel, already chrome-lined and to specification, produced 2 PPSH barrels. The production infrastructure for the Mosin Nagant was vast and long established. By using it as a feeder for PPSH barrel production, the Soviets bypassed what would otherwise have been a significant manufacturing bottleneck. The cartridge, 7.62 by 25 mm Tokarev, was already standard for the Red Army's TT-33 pistol and the earlier PPD. Maintaining a single pistol caliber cartridge across multiple weapon types simplified logistics. On the Eastern Front, where supply lines were under constant pressure and ammunition dumps served multiple units simultaneously, a soldier armed with a PPSH drew from the same supply as the pistol-carrying officer beside him. The Tokarev round delivered a muzzle velocity of approximately 500 meters per second from the PPSH barrel, faster than the 9mm parabellum round used in the German MP40, which achieved around 380 meters per second, and significantly faster than the .45 ACP of the American Thompson at 280 to 290 meters per second. The higher velocity gave the PPSH a flatter trajectory and useful accuracy out to around 250 meters, longer than most submachine guns of the era and far beyond the typical engagement distances at Stalingrad. But numbers on a specification sheet do not capture what the weapon actually was. The PPSH-41 was 87 components compared to 95 for the PPD. It took 5.6 machining hours to produce at the outset of manufacture, later revised to 7.3 hours as production processes were refined, against 13.7 hours for the PPD. The cost, 142 rubles per unit, compared to 900 for the PPD. The preceding weapon had cost more than 6 times as much to produce and taken more than twice as long. For that 142 rubles, the Soviet Union got a weapon with greater magazine capacity than anything Germany was fielding in comparable numbers, a chrome-lined barrel that would outlast the cheaper German steel, and a rate of fire that made a single soldier with a drum magazine the firepower equivalent of an entire bolt-action rifle section at close range. Now, before we get into what happened when these weapons reached the battlefield, if this kind of granular history is what you're looking for, subscribe. It costs nothing, takes a few seconds, and it matters for whether the channel can keep making content at this level. Let's get into how the gun actually got built, because that story is as remarkable as the gun itself. The formal production decision of December 21st, 1940, met the reality of June 22nd, 1941, the date Germany crossed the Soviet border in a state of partial readiness. The primary production facility, factory number 367 in Zagorsk, near Moscow, had been newly established and specifically built for PPSH manufacture. Before the invasion, it had managed to produce fewer than 2,000 PPSH-41s. The numbers were nowhere near what a military the size of the Red Army needed, and events about to unfold would make the shortage dramatically worse. Operation Barbarossa moved with a speed and violence that disrupted every plan. Within weeks, the Wehrmacht had penetrated hundreds of kilometers into Soviet territory. The factories that produced tanks, aircraft, artillery, rifles, and ammunition were directly threatened. Stalin's government made a decision of extraordinary logistical ambition, moved the factories east. From July through November 1941, Soviet authorities relocated 1,523 large industrial enterprises by rail, 667 to the Urals, 224 to Western Siberia, 308 to Central Asia and Kazakhstan, and 226 to the Volga region. Estimates of the total workforce that moved with them range from 10 to 16 million people. The Kirov factory in Leningrad, formerly the Putilov Works, one of Russia's great industrial institutions, was dismantled and transferred to the Urals. Workers at Chelyabinsk were given 75 days to reassemble a steel works that had taken years to build. The first T-34 tank produced at the relocated factory in Nizhny Tagil rolled off the line in December 1941, 3 months after the factory had been evacuated from Kharkov. For PPSH production, this industrial mobilization created an unusual opportunity. The weapon's fundamental design philosophy, stamped sheet metal, minimal machining, simple assembly, meant it could be produced in facilities that had never made weapons. The Moscow network of factories that Shpagin had organized for initial production included enterprises from outside the defense sector. The Small Arms Defense Journal's documentation of PPSH production history records that among the producers were companies including the Moscow Automotive Works and firms with no prior weapons manufacturing experience, converted furniture factories which possessed the sheet metal presses needed for stamping, became part of the production network. Local party officials were made personally responsible for meeting production targets, a feature of Soviet wartime industrial policy that had brutal consequences for those who failed, and which concentrated extraordinary bureaucratic energy on the question of output. The numbers that resulted were staggering. A few hundred PPSH-41s were produced in November 1941. In the following 5 months, December 1941 through April 1942, 155,000 were built. By spring 1942, the production network was turning out approximately 3,000 PPSH-41s per day. Soviet production figures for all of 1942 record almost 1.5 million units. By the end of the war, total production reached approximately 6 million. Germany, by comparison, produced roughly 1.1 million MP40 across the entire conflict. The Soviet Union built more PPSH-41s in 1942 alone than Germany produced MP40s in the whole war. The Germany number is not a failure. The MP40 was a well-designed submachine gun that made genuine use of stamped steel in its construction and was produced in significant quantities, but it reflected German manufacturing priorities and resource constraints that the PPSH design had been specifically engineered to sidestep. The MP40's designers had optimized for quality. Shpagin had optimized for quantity, and specifically for quantity achievable by factories without specialist expertise. The philosophical difference between those two approaches would define the Eastern Front's logistics for 3 years. Against the American Thompson M1928, the PPSH's production economy was equally striking. The Thompson was a fine weapon, reliable, accurate, devastating at close range with its .45 ACP cartridge. It was also expensive, time-consuming to produce, and heavy at approximately 4.7 kilograms unloaded against the PPSH's 3.63 kilograms. American industry manufactured approximately 1.7 million Thompsons across all variants during the war. The comparison is not entirely fair. American production priorities were distributed across multiple weapon types and theaters. But the fundamental point stands. No other nation managed to produce a submachine gun in the quantities the Soviet Union achieved with the PPSH, and no other nation's submachine gun design made that production possible from converted civilian factories. The British Sten gun comes closest in philosophy. The Sten was deliberately designed for manufacture in any workshop that could work metal. Some sources describe it being assembled in bicycle repair shops, and production costs were famously low. But the Sten's rate of fire was approximately 550 rounds per minute against the PPSH's approaching 1,000. Its 32-round single-stack magazine against the PPSH's 71-round drum, and the Sten's reputation for reliability, particularly at low temperatures, was considerably less enviable than the PPSH's. Soldiers on the Eastern Front operated in temperatures that fell below -40 Celsius. The PPSH's open-bolt blowback mechanism, which the weapon shared with many submachine guns of the era, functioned reliably in extreme cold because it had fewer precision surfaces that needed to move smoothly against each other. It was less finicky than more mechanically complex designs. Less could go wrong because there was less there to go wrong. Now those 6 million weapons had to reach soldiers who could use them. The distribution policy the Red Army developed around the PPSH is as revealing as the weapon itself. Initially, PPSH-41s were issued individually to squads within standard rifle units, 1 or 2 per section, supplementing bolt-action Mosin Nagants. By 1942, thinking had evolved. Dedicated submachine gun companies were formed at regimental and brigade level, 100-man units equipped entirely with PPSH-41s. By 1943, these had grown to 500-man motorized submachine gun battalions, whole formations built around the weapon's characteristics, its short, effective range, its devastating volume of fire, its suitability for the kind of assault that would become increasingly central to Red Army doctrine. Cossack cavalry units accompanying tank formations into breakthroughs carried PPS H-41s for the close-range fighting that came when they overran poorly defended positions. The weapon's portability, easier to carry than a rifle over rough ground on horseback, made this practical. By 1945, approximately 55% of all Soviet soldiers were armed with it. The shift in tactical doctrine that accompanied the PPS-8's proliferation is significant and often underappreciated. The Soviet infantry of 1941 was equipped primarily for a conventional war of rifle and artillery fire at ranges where aimed individual shots mattered. The Soviet infantry of 1944 was increasingly a close assault force, trained and equipped to close on enemy positions quickly, get inside the effective range of defensive fire, and overwhelm defenders with automatic volume. The PPS-H made that second army possible. You cannot build close assault doctrine around a bolt-action rifle. You can build it around a weapon that puts 100 rounds downrange in 6 seconds from a package a man can carry at a run. None of this was more visible than at Stalingrad. The battle that began in August 1942 and ended in February 1943 was, by almost any measure, the largest and most destructive single engagement in the history of warfare. Approximately 2 million casualties across both sides. The German Sixth Army, the force that had taken France in 6 weeks, that had advanced hundreds of kilometers into the Soviet Union in months, destroyed. The city that gave it its name reduced to rubble so comprehensive that clearing it after the battle was a project that lasted years. For the PPS-H-41, Stalingrad was the environment it had been made for, even though that environment had not existed when Shpagin designed it. The fighting in Stalingrad was urban combat at its most extreme. Building by building, floor by floor, room by room, the famous factory district, which included the Red October steel plant, the Barricadi gun factory, and the Dzerzhinsky tractor factory, which had been converted to tank production, became a battleground in which the front line moved by meters and distances of 20 to 30 meters separated combatants. Vasily Chuikov, commanding the Soviet 62nd Army inside Stalingrad, developed and formalized the doctrine of what he called the Storm Group, small assault teams of 6 to 8 men equipped with submachine guns, grenades, and flamethrowers who would breach into German-held positions, close the distance before German machine guns could effectively engage them, and fight room to room with automatic fire and explosives. The PPS-H was the centerpiece of those storm groups. Its 71-round drum gave the assault team sustained fire through a breach without the need to reload at the critical moment of entry. Its rate of fire, genuinely approaching 1,000 rounds per minute, meant that in the 2 to 4 seconds between breaching a position and making contact with defenders, a soldier with a PPS-H could put 60 to 70 rounds into a room. A soldier with a bolt-action rifle could put 3. At these ranges, the submachine gun's limited effective range, around 200 meters with the drum magazine, was entirely irrelevant. No engagement in Pavlov's house lasted 200 meters. Pavlov's house itself is the single most famous urban defensive action of the battle, and the PPS-H is inseparable from it. In September 1942, Sergeant Yakov Pavlov led a 4-man reconnaissance team to clear a 4-story apartment building on 9th January Square and found it defendable. Reinforcements arrived, and the building was held for 58 days by a garrison that at its peak reached 25 soldiers, a multi-ethnic force, including Russians, Ukrainians, Georgians, Uzbeks, and Kazakhs, against repeated German attempts to retake it. Chuikov later claimed, with characteristic exaggeration but underlying truth, that the Germans lost more men assaulting Pavlov's house than they had lost taking Paris. The building appears on captured German maps marked as a fortress. The defenders were armed with anti-tank rifles, machine guns, mortars, and PPSH-41 submachine guns. The PPSH's contribution was specifically the ability to defend a position's interior, stairwells, doorways, short corridors, against the type of close assault that a building's geometry demanded. At those distances, it was the right tool. The Germans recognized this. In a testimony to the PPSH's quality, Wehrmacht units regularly picked up and used captured examples. The cartridge was helpful here. 7.62 by 25 mm Tokarev was dimensionally similar to 7.63 by 25 mm Mauser, which some German pistols already used, allowing limited interchangeability. The Wehrmacht officially catalogued captured PPSH-41s as the MP717R and later instituted a program to convert captured weapons to accept standard 9mm parabellum, designating these the MP41R. The fact that a military as fastidiously equipped as the German Wehrmacht bothered to formally adopt and convert an enemy weapon says something unambiguous about that weapon's quality. Soldiers do not carry heavier loads than they must. When German soldiers kept PPSH-41s rather than their own MP40s, they were making a practical judgment about which weapon they preferred to have in their hands in the environment they were fighting in. The partisan networks behind German lines also drew on PPSH supply. The weapons were airdropped to resistance groups across occupied territories, and partisan gunsmiths produced improvised copies. The basic design's simplicity meant that a machinist with a metal press and rough materials could fabricate functional approximations. Soviet partisans in the forests of Belarus and Ukraine used PPSH-41s in the ambushes that made German rear area security a persistent operational problem throughout the war. What happened after the war is its own kind of vindication. Production ceased in the Soviet Union in 1947, but spare parts continued to be manufactured until 1955. Licensed copies proliferated. The Chinese Type 50, produced in large quantities, saw use in the Korean War and was still in the hands of Viet Cong fighters as late as 1970. North Korea produced the Type 49. Yugoslavia produced the M49. Romania made the PMPPHMD 1952. The design spread across 4 continents and 4 decades of post-war conflict. A weapon designed in 1940, manufactured in furniture factories, optimized for production by the unskilled. It outlasted most of the sophisticated weapons designed by better funded, more expert industrial programs. The comparison that closes this story is the one that matters most. The German MP40 was produced by firms like Irma and Heinel, precision manufacturers with decades of experience in weapons engineering, making a weapon to tolerances and standards that German industry was justly proud of. Approximately 1.1 million were built across the war. The PPSH-41 was produced by furniture manufacturers, automotive body shops, converted civilian enterprises whose workers had never held a weapon design drawing. 6 million were built, and by 1945 they armed more than half the Red Army. The cost of the PPSH-41 was 142 rubles. The cost of the MP40 was approximately 57 Reichsmarks, roughly equivalent in purchasing power within their respective economies, but the PPSH was produced at 6 times the volume on a fraction of the industrial basis. Return to that machine shop in the Barricadi factory, October 1942, the ruined building, the narrow corridor, the 2 soldiers at 6 meters. The Germans' bolt-action rifle is the correct weapon for the Russian steppe, for the advance across open ground that German commanders had expected this war to resemble. It is the wrong weapon for this building, this rubble, this distance. The man with the PPSH-41 is holding a weapon built from stamped sheet metal by a carpenter's son who taught himself engineering in an artillery repair shop, manufactured in factories that made furniture 6 months ago, priced at what a Soviet worker earned in 2 weeks. It is not the better engineered weapon. It is not the weapon that reflects more industrial sophistication, more design expertise, more manufacturing precision. It is the weapon that was there, in enough numbers, in the right hands, at the moment that decided the war's outcome. Stalingrad fell to a weapon built in furniture factories because the Soviet Union understood something that manufacturing wisdom has since formalized into doctrine in a war of industrial scale. The weapon that can be built fastest and cheapest and by the most people wins, provided it works well enough when it matters. The PPSH-41 worked 6 million times over.